This week saw the final launch of the SpaceX Starship as we know it. And it's pretty hard to imagine a more perfect send-off for the first era of STARBACE. The biggest story of the day is actually the promise of what will come next. But first, let's take a look at Flight 11, which was the closest thing to perfection that a Starship test has ever offered us. All that begins with the previously flown Super Heavy booster. This is the same rocket we saw launch on Flight 8 in March 2025. The booster was returned to the trajectory for some cleanup and refurbishing, which include redeploying some of the engines. But we still have 24 of the original Raptors from Flight 8 returning for Flight 11, and they performed beautifully. By now, everyone knows what a successful Starship launch looks like, and this one was no different. A beautiful Ascentinto, a clear blue evening sky followed a hot stage separation, and the boosters returned back to the surface. This time around, SpaceX did have a new experiment for their booster landing barn. Just like the two previous flights, this one was not going to be a tower catch. Instead, they are bringing the rocket down over the water. And that gives them the freedom to try something new without worrying about any consequences. So instead of doing the usual procedure, where they start landing with 13 engines and then drop down to 3, they are instead going from 13 to 5 and then to 3 engines right at the very end of the landing. SpaceX says that this is a test run of new procedure for the next booster V3. It's basically just going to use a little bit less fuel for the landing burn, which means there's more fuel to burn for liftoff. Meanwhile, in space, the Starship is making its way flawlessly into a suborbital trajectory around the globe. All that we're really looking for here is that the ship remains in control the entire time and nothing blows up. So not only did Starship maintain control throughout its coasting phase, it also gave us a pretty amazing demonstration of what those wing flaps are capable of when they don't end up melting away during re-entry. At around T+8 minutes into flight, and at an altitude of 50 kilometers, Starship begins its first planned dynamic banking maneuver. That's essentially their first attempt at changing course in mid-flight. So instead of letting the ship come down naturally in a straight arc, they are steering around in a kind of semicircle patch as it drops. This is a critical test for future landing attempts when the ship is going to return to its own launch site. It needs to gradually steer itself up from Mexico over to Starbase, Texas. Then just above the ground, the ship needs to make a final twist maneuver to align itself with the tower and catch arms. We can see the ship practice this turn at T+1 hour and 5 minutes. It spins itself around about 180 before making the final downward flip and igniting its engines for the landing burn. Even with all of that steering and changing in direction, the ship somehow still manages to land right in target beside the floating boy Chimera. And we see it splash down lightly before tipping over and exploding. Now, that is the last time that a Starship launch will ever look like that. Flight 12 is where the new chapter begins. And that means if everything from the ship to the boosterdo, the launch pad, will be totally different next time around. The next iteration of the Super Heavy booster is going to bring a totally new look and a lot more power to the table. Starting at the base of the new Super Heavy, it's still going to have 33 engines. But these will be the Raptor V3. Of course, the new engines come with more power. An increase from 230 tons of thrust up to 280 tons. But more importantly, we are getting a much more simplified engine adhesing from Raptor 3 with this dramatic reduction in visible parts. Basically, every hose and wire from V2 has been brought inside the engine casing. This is not only easier to build, but it's also going to be more reliable in flight because there's less stuff being exposed during launch and re-entry. SpaceX says that the Raptor 3 testing phase is now complete, and the first flight-ready engines are rolling off the production line as we speak. Moving up the booster, the overall length is going to be stretched out a bit to accommodate a larger fuel tanks to feed those new engines. That new fuel system includes this massive transfer tube that allows liquid methane to flow down from the top of the booster to the engine bay. For scale here, that new transfer tube alone is about the size of a Falcon 9 booster, a rocket within a rocket. And it's at the top of the new super heavy that things get very interesting. The first change you probably notice is that we've gone from 4 grid fins down to 3, and they've repositioned the remaining fins into this T-shaped pattern. It looks like their main reason for doing this was to integrate the catch pin fourth chopstick arms into the structure of fin itself. To accomplish that, each grid fin has been beefed up by around 50% to make them bigger and stronger than before, which seems to have given SpaceX enough confidence to remove one fin entirely. We know that deleting parts is Elon Musk's favorite design philosophy. So now we're going to find out whether they end up having to put it back or not. Then above the grid fins is something totally new for the Super Heavy, an integrated hot stage connection. For every launch since Flight 2, SpaceX has used a hot stage separation to push the ship away from the booster. And that's always worked great. But it always required an adapter to be placed in between the two. That will protect the booster's fuel tank from the engine flame and allow leak-housed gas to escape out to the sides. That interstage adapter might seem like a small thing, but it weighed about 10 metric tons and had to be dropped into the sea after the separation was complete. So it's not a sustainable internal solution. That's why the new booster has this triangle pattern of support beams at the top that provides a lot more open space to vent the exhaust gas. And in the middle is this new reinforced dome section. That's actually the top of the methane fuel tank. And SpaceX has welded on these extra layers of steel in strategic locations to protect the tank from engine fire during the hot stage. Moving up the Starship itself, the V3 is going to look pretty similar to the existing design, but on the inside, it's getting a lot of new upgrades. Now, the current V2 ship is probably best known for having some reliability issues. Most of them experience a rapid unscheduled assembly of one kind or another. And as far as anyone can tell, each one of those failures was able to shed light on a different issue with the overall design. SpaceX has spent this entire year finding problems, fixing them, and finding new problems, and repeating that process over and over again. Up until the previous flight test, number 10, which was mostly successful, but we did see the ship get rocked by an explosion in the engine compartment that shredded woe of the rear control flaps prior to entry. So after learning from all of those mistakes, the engineers at Starbase have completely redesigned the fuel delivery system for Starship V3. This rocket is also getting the upgraded Raptor engine, which should prove to be a lot more reliable. With all of that combined, this new Starship Super Heavy is going to be capable of deploying somewhere between 100 and 150 tons of payload into low Earth orbit. That's going to put it on par with the capability of the old Saturn V moon rocket from the Apollo program. Only Starship will also be fully reusable, something that would have been considered impossible back in the Apollo days. And speaking to that reusability, SpaceX gave us the most detailed preview unit of what an orbital docking and fuel transfer is going to look like. The exterior of V3 ship is going to be fitted with new docking adapters on the backside opposite the heat shield. And then it looks like there will be tokens of Starship, one with male adapters and one with female, or one built for sending and one for receiving. Whichever way you want to look at it, and after making that connection, those ships are going to transfer liquid fuel between them, which will allow their receiving ship to fly higher into space and reach new destinations. SpaceX has said that this new Starship V3 is not final design, but it will be the one that first lands on the Moon and Mars, or attempts to land, at least. We'll see how that goes. And then supporting aloft, This will be a new and improved Starship launch pad and catch tower, often referred to as Stage 0. Flight 11 will be the final launch from Tower 1, and it will be the last time that SpaceX uses their upside-down showerhead flame diverter. Tower 2 has a more traditional flame trench and water deluge system at its base, the same as what you'd see underneath the Falcon 9 dot, and then the tower itself will be taller and stronger than before. But the copstick arms will actually be much shorter than the original Mechazilla. The reason for that is pretty simple. Smaller arms can move faster and will be more stable. When SpaceX built the first set of arms, they'd never caught a rocket before, so they didn't know how much surface area they would need. Turns out not very much. So now they're building smarter. That gives us a lot to look forward to, which is great news. It means that the next chapter for Starship will bring new and exciting times all over again. So stay tuned. A 2025 orbital reusability review found that Starship's dynamic banking maneuvers and precision splashdown tests have achieved the highest controllability metrics to date, validating future tower catch operations for flights beyond Flight 12.